Our second speaker of the evening is Grigg. So Ian has had 25 years of experience as a senior software engineer, is well known in the field of financial cryptography. He's the inventor of the Ricardian contract and also the Ricardo transaction engine, which is used in projects like CommonAccord, OpenBazaar, and Eris Industries. Without further ado.
Okay, thank you. Yeah, so they asked me to pick my own topic, and what I was really interested in was some thoughts about where we're going with the architecture of the blockchain and so forth. So something that's come out of my mind is whether we can converge all of the different ideas that are out there in identification terms. So this is more like, it's a thought process, it's coming bit by bit, it's really, if you like, quite young in its evolution, and a lot of people will say it's complete crap. But here it is. See if we can converge. It's got various names, like the sum of all chains, and so forth and so on. So imagine there's a person. Now, if there's a person like that, well, we've got a picture there. You can imagine that just by looking at the picture. What else is there to say? Not a lot. But now we've got another person. This one's Bob. So this one's male, blue. What does that mean? Well, what it really means is we've got two people. We've got some differences. We've got to give both of them names. So naming only becomes important when we've got a few things, a lot of things, which is somewhat critical in some areas. So what is identity about? It is, in this context, it's about the difference between these entities. Alice versus Bob, there's names. We've got things we can look at with any particular person, age, gender, male versus female. So we can just do the old ontology thing and collect all this information up together. That should be sufficient. Oops, what happened here? Ooh. Yeah, identity, but things can be a bit tricky. Gender used to be quite simple, but it can be unknown, it can be unstated, it can change, this relatively new phenomenon. And this is this random slide I pulled off the net last night when I was doing some slides for this show. And down there in the red, I'm by gender, so please use they. And this brave person, they have gone out on the net, and they're interested in secure properties of naming via object capability systems, which is really interesting. That's what we're talking about here. And they want us to refer to them as they. This really mucks up gender completely. We can no longer use binary assumptions. So how do we deal with this? There's a trap going on here, a trap of over-measurement, a trap of ontology, which leads to paralysis if we're not careful. Why does it do that? Never mind. So imagine a group of people. What happens when you get a group together? It can be called a corporation. It can be incorporated. We might need a number. We might need a type. We're going to need rules and regulation. Well, somebody will put regulations on top of us, but we'll need our own rules. So we've got quite a lot of information to collect. But we can go further afield. In times historical, you probably remember the old sea stories where they would talk about the ships as having names and the engines having names. And even in modern day times, computers have names, programs have names. ELIZA is a famous old psychology analysis program. HAL from movies, Skynet from movies. And when the internet first started up, it seemed like every second machine was called Gandalf. There's lots of attributes you can collect about these things as well. Can we identify machines in the same way that we can identify people? Why not? Now we talk about a smart contract. A smart contract is, well, it's out there. It exists. It's permanent. It's got some sense of reality. So whatever we think it is, I mean, I personally think it's a state machine with money, and there's lots of people hunting around for definitions to try and understand this. Whatever we think it is, we can measure it. We can find its location. We have to find its location because we've got to talk to it. We can find its code. Certainly in the blockchain instantiation of the concept, its code is everywhere, and it's running. We can find its state if it's a multi-state machine, and those are the interesting ones, I think. And it probably has to have a name, because it probably needs to market itself out to the world, and you can only really do that with a name. So you can collect this information. If we can do a smart contract, why can't we do a blockchain? With a blockchain, well, there's certainly a location. There's a bunch of IP numbers out there. There's a bunch of places we can talk to it. There's a lot of technology types out there, and these are important in knowing how to interpret the results coming back or how to talk to it, protocols and so forth. There's a list of a few of them that I just happen to be aware of, but hey, there's lots and lots of them. There's a controller, or probably there's a controller. For example, in Bitcoin, there's an alert signing key. There's DNS seeds. Thelonious, for some reason, has a smart contract at the beginning, which is interesting in itself. And it has a name. Probably a bit of a surprise to a lot of people. There are 4 Bitcoin chains. One's called mainnet. That's the one you're used to using. Then there's a test net and a something else net and something else. So if we can have a mainnet, can we have AliceNet? Can we have MyNet? Yes, in theory we can. And actually, if you're in the business of doing interesting stuff with Bitcoin, you probably want to talk to corporates. And when you go in to talk to corporates, they probably turn around to you and say, you know, love the concept, but we want our own one. We want to run our own blockchain. We probably want a side chain, or there's a bunch of other names for it. And we want to tune the params. We want to change it so that the performance is different. We want it to go faster, or maybe slower, more security perhaps, more space, whatever it is. We want money rather than smart contracts, or smart contracts rather than money, or whatever. And if you're talking about contracts, they probably want a legal environment, because they do legal environments with everything else. When you walk into the building, there's a contract. If you walk onto a train platform, there's a contract. It's posted up somewhere. If you buy sweets in a shop, there's a contract. So corporates will probably want some sort of contract in there. So what's going on? Then there's side chains. Now, side chains are becoming interesting because they break a lot of the assumptions. The interest behind side chains has a lot to do with multiple assets, putting multiple assets in there, such as some people like Counterparty or color coins or those variants are trying to do. Sidechains are trying to do it as well, but they're also trying to do it in a proper fashion. So that means we also need to do things like separate the Genesis block out. The Genesis block needs to start the chain, not the currency. We need a separate Genesis for the assets. And we also need chain identifiers. This is a consequence of moving value from one chain to another. It's a side chains thing that sort of popped out the side. If you're moving coins between different chains, you then have to move them back again. If you want to redeem them from the original chain, they must follow the exact same path. Otherwise, you get a problem if 2 coins come from the same base chain, go by different paths, and then end up on the same side chain. Something we call diamond coins from time to time. So where's this all going? We need to make some sort of changes, and we can look at the blockchain, how it's done, and make a few changes. And it sort of works out that if we take the bottom layer, we've got a bunch of parameters. Let's talk about the parameters in a blockchain first off. These are hard-coded, but they exist. They are in the blockchain software, hard-coded into the source code. So we need to get those out. We need to get those out into some sort of description if we're going to have hundreds or thousands or indeed millions of blockchains. And it's probably a good idea to stick a smart contract in there that its purpose is to start off the blockchain, just for that purpose. And also, I've talked before about the legal contract. When you're going into a corporate context, you probably need that contract sitting there, and we're talking text, we're talking legal terms and conditions, blah, 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 in there locked in. And then you also need an instantiation. You need that event, that thing to make it happen, and that's what I've labeled there as the Genesis transaction. So somehow these things all need to be brought together, locked into the Genesis transaction, and out the top, pops out an identifier. That identifier can then be used by the software in various and many ways, such as getting the particular properties out to deal with that technology, such as moving value from one chain to another. So this is a particular picture. It's a slight variation of what's going on with the current blockchain technology, but it leads in to the rest of the devices. Let's talk about a DAO, Distributed Autonomous Organization. What is that? I'm not entirely sure what it is. I don't think anybody is. But it's a sort of corporation that doesn't have an instantiation in normal terms. It's a thing that's out there that does stuff. It's like a magic corporation. It probably lives on a chain somewhere, so it's got a location. It's probably controlled by somebody else. So it might be autonomous, but who would set it up for autonomous reasons? I mean, what's the purpose of that? It doesn't make a lot of sense because these things generally want to make profit, so the profit needs to go somewhere. So like corporations today, you expect controllers. It probably wants to make contracts with other DAOs or other entities out there. So it probably needs to do some signing, which means it needs keys, code, smart contract, state. It needs accounts and capital. It needs a whole bunch of stuff, and it has a name. It's got to market itself, so it has a name. What am I saying here? It kind of looks a lot like the other things. Issuance, just to quickly flick through this, a lot of issuances have existed in past. Bitcoin is not the beginning of this space. Before that, we've had the pound sterling for how many hundreds of years? That is an issuance. Cyberbucks was issued in about 92 as a digital currency. It was just given away, but it was there. And the Chorm's company, DigiCash, issued about 750,000 of these before he was told to stop doing that. PayPal came along, and of course we all know the story there. It was an issuance. DigiGold was a gold metal-based currency I was involved with back in the early 2000s. Then it was quiet for a long time, and along comes Bitcoin and a few others. They all have things in common. They all had an issuer in some sense or other. You could possibly dispute it with Bitcoin, but, you know, I mean, Satoshi was there. He started up the software, so he's essentially the issuer, even if unstated. It's got types of technology, types of value, so is it shares, bonds, etc. There is some stuff about symbols to print out. The user wants to know what it looks like on the screen. Is it GBP? Is it BTC? What do the units mean, the subunits? How many decimal points? Stuff like that. We need to know how minting is done. That's hard-coded into Bitcoin, but it doesn't have to be. It could be in the Genesis identity package such that we can tune the parameters. There needs to be a controller. As I pointed out, there are some vestiges of controlling going on with the Bitcoin blockchain, and in future blockchains will have more control. Issuances will have control, because typically issuances are done by issuers, and issuers are controlling entities. You want them to be in control because they're making legal claims, which brings us to terms and conditions, which is to say you also need that contract. What are we saying? It's starting to look, it's looking a lot like the other things. It's got the same elements. So where I'm coming to is that there seem to be a list of what I call first-class persons in this, this new space. They all seem to have about the same set of characteristics. We've got humans, they do stuff. They've got corporations, they make decisions. DAOs apparently are out there trying to make profits. Smart contracts are making decisions on the basis of inputs. Chains are running and are persistent and are supposed to be there. Issuances are supposed to serve your value storing needs for quite some time. Internet of Things. You know, it's funny. It might look a little bit hilarious, but actually your fridge is sitting there with a chip in it, and it can do things. It can run a smart contract. It could run part of a blockchain. It could do anything you like. So it's got all these attributes. It could act as a first-class person. What do these things need, the first-class persons? If you line them up on the top there and put down all the stuff I've talked about on the left, it turns out you can fill out the table and pretty much everything needs everything most of the time. Yeah, sure, there's some exceptions, but you know, that's just life in the IT business. For the most part, they all look pretty much the same. What do these things do? Just quickly, well, we've got to instantiate them. They all communicate with each other. They need to name each other, and they need to take that name and send it to other entities. So we've got to be able to reference Bob, and furthermore, we've got to make claims about Bob and send them on to Carol. So we've got to actually make some sense of delivering information about these things. So it's got to be a decently good reference. All the normal sort of IT stuff like identify, share, change, find, probe, blah, blah, blah. So what is a person? It turns out that one of these first-class persons has various attributes. They can do decisions. They're apparently intelligent in some sense or other. They've got state. They're holding value. They might be holding money or shares or something. Photos, who knows? They're permanent. And coming back to the question, no, there wasn't a question, was there? There was a statement. Before, in the last talk, they have intent, which is a legally significant word. So we're all the same. We're all the same. We people are the same as smart chains, same as blockchains, etc., etc. We should be able to make a recipe that describes us. We should be able to collect all these things out, and we should just look the same. Of course, we're all different. The fields in these particular things will all be different, but that's fine. That's what we as IT people know how to do. We can handle that sort of stuff. But you know, what I'm getting at here is you can actually do this, collect up all this information, but doing it isn't quite as easy as just saying it. There are a bunch of things that we have to worry about. It's got to be tractable. That is, it's got to be relatively small and powerful at the same time. We've got to be able to contain text and code together, which makes it quite tricky, but you know, we've got to do that. It's got to be accessible and easy to implement, which probably means we don't want XML. It may mean we could do JSON, but actually I prefer just line-based tag equals value because anybody can read the stuff. Nobody has to worry about it, and it's easy to write a parser. Various other things. It's got to be able to include its own PKI. It can't really resort to an external PKI. It's got to be able to be in control of its own destiny, which means it puts its root key inside itself in a sense that is perhaps familiar to the PGP people. And it's got to be able to sign things to show its intent. We need an identifier, and the easy thing is just to take this package that we've built up and take a hash of it. That's really good. But there's a little thing called Zuko's triangle, which I won't go into, but if you're into this area, really need to grok Zuko's triangle. Basically, it says you can have an identifier with these attributes, globally context-free, securely collision-free, human meaningful, but you can only reach 2 of them with a single, simple system. So what we say is we've got to take the basic system we invent and then square it to get the other attribute. That's getting a bit too much detail today. So in observing all this, what are we seeing? I'm trying to capture a lot of diversity and wrap it back in to one particular archetype. So we've got to capture this code, text, and params and make it work together, get it instantiated, and get that identifier out. The identifier is probably the easy part, although you'll probably notice I'm skipping something here. What I'm not talking about is what we do with that identifier once we've got it. So I might come to that. In a sense, what we're doing is objectifying. And if you're an OO programmer, or object-oriented programming, this should be relatively easy to understand. We're all objects. We just need to create the object archetype to be able to manipulate all these things. Yeah, and a few things which are interesting if you're actually implementing it. So what does it look like? Triangles. We love triangles in this game, apparently. It looks like there's a legal contract, a bunch of parameters, which might or might not be in the legal contract, and then there's a smart contract, which basically means some code, which sits there and runs as a machine. And it might or might not include some of the parameters as well. Those 3 elements together get wrapped up into a package and shoved in as a Genesis transaction into something. There might be another blockchain, it might be a server, It might not even be what we think of as a transaction or a genesis, but it looks approximately like that. So I'm borrowing the buzzword. And out of that package, we get an identifier. That's kind of what it looks like today. I will admit, yesterday it looked a little bit different, and I've added a component in there. So maybe next week it'll look different again. Now, some people on the net are actually already figuring this out. They're racing ahead. So here's one which I particularly like. CommonAccord, they're a group that is doing legal contracts, wrapping them up into little tech objects, object-oriented stuff. So they have a piece of code, which they call an object, and they put it into an archive somewhere, and they have a matching legal document which relates to it. And what you do is you go piling through their system, looking for legal clauses. You pull them out, compose them all together into a big contract. And with each little legal clause you pull out, it comes with a bit of smart code. So you end up creating the whole smart code system and the whole legal document at the same process. And they're basically doing the same thing, wrapping together a smart contract with a legal document and then creating some sort of identifier out of it when they produce their final contract. So it's out there. There are other people doing things like that as well. How do we do this with everyone? Well, it's not that easy. There's some open problems, so I'll list them here in case people are still following on what I'm talking about here. How do you mix the code and the text together? This is kind of unsolved. The code can be very big. It might not fit in the blockchain. The text can be very big. Derivatives contracts can run up to 300 pages. That's not happy. We don't want that in the blockchain. So you'll find that some people out there have figured out that in order to do a new generation blockchain, they're having to add some sort of file store to it. And it's for things, it's reasons like this that we need a file store. We need to take the Genesis concept and break it out. The Genesis should be just to start the chain, shouldn't start the currency. We need to start a currency in a different transaction. We can still call that a Genesis transaction. We've just got to break that out. And that's already been done in some of these systems. And then there's the other identity. Having put all this together, I haven't said anything about whether this is safe, whether you know the other person is who they are, whether there's any recourse, whether there's any intent or a person behind it or what. We really don't know anything more than what the text says. And basically what I'm going to hand wave about and say is, yeah, that's a subject for another day. But it does kind of lead to a bit of a conflict in that all of this is about surfacing more and more information, getting more and more information out there, which is great for security. We're locking things down. It does rather leave aside the question of privacy. Are we ruining things for privacy? That, again, is another question for another day. And that's it. There's some references. We're done.
Awesome. Thank you very much, Ian. So we're going to open it up for questions for 10 or 15 minutes. Again, I'm going to be beside my favorite pole. So, yeah, if you want to ask a question, come over here. Go on, Preston.
Hi, and how you doing? As you know, I'm a huge fan of your work. But just to sort of clarify how we approach the problem with Thelonious. So when you deal with legal obligations in a data structure, you have two options. You can either try to get the data structure behaving like Bitcoin and have it sort of have its own character and its own person, or you can hack. And so the hack that we found was that you draw a very bright red line between the legal obligations and then the programmatic mechanics which you're using to run the blockchain. So basically your blockchain is run according to a set of instructions, and then you model the software to fit the legal obligations and hook in. But going forward, it may be that the networks have their own independent character, but for the time being, I think one approach to take, and the one we have taken, is to look at the blockchain legally as just a pass-through vehicle. So it's effectively it's there, it's mediating interactions, but you look back to the user or the agent who's actually giving the instructions when you decide how you're going to structure how the software works.
Yeah, so that's a really interesting area, and I think it kind of gets to the core of what I was trying to say there. I say that there should be a place for the legal obligations inside the blockchain, just for the blockchain, you're saying, no, you don't need that. Well, in some circumstances, I entirely agree. Where I think it's going to change is when you walk into a corporation and you say, we've got this great technology, and they'll turn around and say, yeah, now can we wrap a contract around the whole thing? And that's a debate that is either going to happen or not happen. I'm just kind of predicting the future there. But yeah, what was your question again?
Oh no, it was just a general point for sort of the audience to.
Yeah, I know you didn't ask a question. It's fine.
Andy, do we get a hug or not? You always get a hug. Good. Has anyone else got any more questions? Thank you very much, Ian Grigg.